applications now of some of these trig functions that we can use. So this is chapter 8, section 5. We got angles of elevation and depression. Kind of a simple concept. Angle of elevation. And spelling helps. An angle of elevation is taking your line of sight as if you were just normally looking forward and looking up. So from your line of sight, this is not walking and looking at your cell phones, just walking normally looking forward. So it's a line of sight to something above. Walking down the street, looking where you're going. Oh, look, a bird. So you then turn your head and look up. This is the angle of elevation. Angle of depression. Angle of depression. You're walking, minding your own business, and a bird's flying and looks down at you. So from your line of sight, to something below. Line of sight to something below. So here's your bird. They don't look at cell phones. They pretty much look where they're flying. Now, obviously, when they're gliding, they can look down and stuff, which is what you're going to see. There you are, walking, minding your own business. Look, a person. So, line of sight, down, angle, depression. As we know, the TV used to be 27 feet tall in our room. Notice what we have going on here. Their altitude to where you're walking, angle of depression. Now, the angle of depression's here. It's not quite inside this right triangle. Should you be able to figure that out since there's a right angle here? Yeah, they're complementary. Or get the crazy thoughts going, parallel lines. So the angle of depression is the same as the angle of elevation. Parallel lines. So as we do that. So please pay attention to what's going on here with these right triangles. Jump back up to this one. Now, in this one, I go straight up. Notice where my right triangle is. Now my angle of elevation is inside the triangle so I can use it. Be very careful. That's going to throw some of you sometimes. Now, look. This person is not laying on the ground, so I would have to get this height to add on to whatever I have here to figure out the bird's height. Little things. Got to pay attention to these drawings. Really simple. You're going to use sine, cosine, tangent. But you got to understand where your angle of elevation, where your angle of depressions are located. So let's try two examples here. Let's go to our bird example. So there you are, minding your own business, walking down the street, or walking wherever you see a bird way up there. So there you are walking. There's the bird. You know that the angle of elevation that you're looking up to the bird is 38 degrees. I'll explain this later. and kind of wonder how high off the ground that bird is. And for whatever reason, you're 236 feet away from it. So I got to find this. Now, here's what I'm talking about. You got to know what's going on. First of all, the angle of elevation is in the right triangle. So we're in business there in terms of having to worry about inside or outside the triangle. So we're going to figure this out. But remember, this is from your eyeball up. Is that all the way to the ground? No. If you're walking, you're not laying on the ground. So we'll have to estimate or figure out how far their eyeballs are off the ground. Let's say their eyeballs are 5 feet. They're a 5 foot, 4 inch person. So the eyes, approximately 5 feet. I understand from here down is the other part to get that bird to the ground. In this particular example, we didn't take the reading from the ground. That's okay. So let's work. I got an angle. I got this, which would be the adjacent side. I got this, which would be opposite. What trig function is that? Hopefully you are all screaming tangent, which is, that's set up right there with my triangle. So let's plug in. I got the tangent of 38 equal to x over 236. Cover it up. Tangent times adjacent side. So tangent of our angle, 38, times our adjacent side, 236, equals. So the bird's approximately 184 feet in the air. Stop. That's for right now. That's from 184 is this, from here to here. Remember, we got to have their eye height on there, so add another 5. So the bird is roughly 189 feet in the air. All right, example number 2. Summer's coming around, going to the beach, going to different places, so you got a lifeguard sitting on an elevated tower. Yep. You know who you artists are. You can draw some better ones for me. I'll be more than glad to use them. So they're here. There's your beach. You got out the water. There's somebody swimming. Looking out, because as lifeguards do, they're always surveying the situation. They notice a swimmer at an 8-degree angle of depression. 8 degrees from here to here. They are 6 feet above the ground on their tower. So the question is, how far away? So this is one where we got to pay attention. A couple different things can be done here. We got to find this distance. That's what we got to find. We're assuming our tower is perpendicular. So that's 6 feet up in the air. And we got to find this distance, and we know this angle. So people look at it a bunch of different ways. Alternate interior angles of parallel lines. So you could say that's an 8-degree angle there. Use that as your reference. Right angle with vertical horizontal. So some people will use a 92-degree angle there. Listen, kids, I don't care. They both work. Or, I know, it's the third variable here. Some people use this right triangle up here. Going straight up from where the person is, there. You're still trying to do what? Find that same side. Doesn't matter how you do it. So, what do I want to do? Let's say I want to use the 92-degree angle. Okay. Here is my reference angle. I have adjacent. I'm trying to find opposite. So I'm doing the tangent of 92, by the way, TOA. And I'm setting it equal to opposite over adjacent, x over 6. Or, because that person's the same distance away, you can do it from their point of view. Opposite adjacent. You can do the tangent of 8 equal to that. There's your two best setups right there. So let's figure it out. Okay, tangent. Let's do them both. Tangent button right there. Tangent, close it. What's my fraction tell me to do? Right there. Tangent times adjacent times 6.